So 1/6 is a pretty big lesson, so we split it up into 2 days today, and then we'll do the next on Monday. So today we're going to focus on absolute value equations. And on Monday, for the part B of this, we'll do absolute value inequalities. So absolute value equations, we're going to be solving for x today. Well, let's talk about absolute value. You know absolute value. You know that if you take the absolute value of -10, what do you get? 10. If you take the absolute value of 10, you still get 10, and that's weird. So how can that same thing give us 10 right back? Well, absolute value is just basically it's the distance from 0, and distance is positive. So if I'm standing right here, let's say at 0, and I tell my kids, hey, I'm tired of you, go at least 10 feet away from me. Or go 10 feet, exactly 10 feet. We're going to do at least on Monday. They can either go here or they can go over here if I'm standing on a line. Okay, we're just one-dimensional right now. Don't you agree? I say, get away from me, just 10 feet. So they can go here or here. I don't actually say that to them. Okay, yeah, I do. All right, so here we go. If you have an equation, though, so here we go. We're going to start with part A. We're going to do an equations. So if you have an equation like this, the absolute value of x is equal to some number A. Okay? Then this is what's true. X can equal either A or x can equal the opposite of A. So maybe sometimes it doesn't make sense when you're using variables. So if I said, for example, the absolute value of x is equal to, Connor, what number is your jersey?
6.
6, perfect. Does that mean you're a receiver?
Yes.
I know nothing about football. I'm very impressed with myself right now. All right, absolute value of x equals 6. That means that x can be one of two things. X can be 6 or x can be -6. Right? Think about it. Wouldn't those both work if you plug them in? Yeah? Good. Okay, now that's the easiest of the equations. We're going to do some harder ones now. Much harder. Here we go. Number 1, we're going to solve and graph. All right, we're just going to graph the first one. We're going to solve all of them, but we're going to solve and graph. I don't know why they want us to do that, but we'll do it. Here we go. Absolute value of 2x minus 1 is equal to 5. Okay. Now, the first thing you need to do in these problems is you need to isolate the absolute value. Right now, it's isolated. There's nothing around it. By stuff around it, that means like on the outsides of it. Over on the left side, it's just the absolute value. So what I'm going to do is this. I'm going to say that the stuff inside of here, that stuff in there, think of it as one whole clump of thing like that earwax I was talking about. That stuff right there can be either 5 or -5. Do you agree? All that stuff to make the absolute value 5 equal, you know. So then what we do is we set up 2 equations for ourselves to solve. 2x minus 1 can be 5. Or 2x minus 1 can be -5. You see that? You agree with that. You knew it. I saw some of your heads go, yep. And so now we get to solve 2 equations. Yes, it's twice the work. Yeah, okay, so groans. Add 1. 2x equals 6. So x equals 3 is one answer. Okay, the book will say to check your answers. You don't have to. Maybe if you're a little extra, you might. Or if like you're going to take a quiz and you want to see if you got them right, you might want to, if you care about your grades. All right, or x equals -2. Both of those will work in this equation. 2 answers. Have you ever solved and gotten 2 answers before? Yeah, probably. You probably have. You know there's 2 answers to this. X squared equals 9. 2 answers. What are they? 3 and -3. Good job. Yeah. Okay, I get off track. All right, number 2. Now let me do one with you that does not have the absolute value isolated, and I'll show you how to isolate it. So suppose that you have 3 times the absolute value of x plus 2 minus 1 equals 8. 3 times the absolute value of x plus 2 minus 1 equals 8. Now, I like to tell you what people do wrong so that you won't do that wrong thing. People will get this, and they'll set this whole thing equal to 8 and negative 8. And that's incorrect. Oh, you found it. Good. Okay, you have to isolate the absolute value before you set up any extra equations to solve. So what you're going to do is you're going to think of this absolute value whole thing as a big clump. Like that's your variable that you're solving for. And we're going to add 1 to the other side to get 3 times x plus 2 equals 9. Now that's a times right there because it's next to it. And you can't distribute like parentheses. That's not a parenthesis, it's more like a wall. Okay? So what you want to do is you're going to divide both sides by 3. So we're isolating that absolute value. We're getting all the junk outside of it, around it, over to the other side. So those are gone. And now you have the absolute value of x plus 2 equals 3. Okay, now we're ready to say all this stuff in here can either be 3 or negative 3. So x plus 2 can equal 3, or x plus 2 can be the opposite of 3, which is negative 3. Okay, do you get this?
Yeah.
Yeah, pretty good. Get all the other stuff around, and then set up your 2 equations. So let's solve. X can equal 1, or, oh, I didn't graph that first one, did I? Whoopsie whoops. Or x is equal to negative 5. 2 answers there. Okay, when it says to graph your solutions, this one's kind of lame. I like to graph inequalities because that has an arrow and some stuff going on. This is just x equals 1 or x equals negative 5. So that's what the graph solution would look like, just 2 points, 2 dots at those 2 answers. It's kind of silly.
Why didn't they make it through that?
I don't know. Sometimes they do weird stuff. I like to skip the weird stuff, but that time I didn't. All right, number 3. Now I'm going to mess with you. Here it comes. The absolute value of 2x plus 1 is equal to negative 12. Yeah.
I just have a question.
Sure.
What's the point of having the lines?
Those absolute value lines?
Yeah.
That makes things positive, basically.
But what if you don't use them?
Then if they're not there, like if these absolute values weren't here, it would just be a basic equation like this, and you only get one answer. It's just the equations we've done before. But because that absolute value is there, it means we're going to get 2 solutions for these problems.
Okay.
It changes it quite a bit, actually. When you get to this step, and you say the absolute value equals 3, then this in here can be 3 or negative 3. So it changes the whole problem. Okay, now if you look at this and you're okay, you go, okay, this is isolated, so I'm just going to set this up as negative 12 and positive 12, and you're doing your steps. No, stop yourself. Don't do that. Can an absolute value equal a negative number? No. I know. You get so used to just doing, like, oh, I'll put 12 and negative 12. But no, that's a negative number. And an absolute value can never equal a negative number. And so your answer to this would be no solution. You're going to like those because you know what? You don't have to do anything. That's all you do. You look at it and you go, nope. And then you move on, right? Can an absolute value equal negative 12? No, it can't. Okay, now, knowing that, people will mess up this next one. This is the last one of part A, and we only have part B. So it's pretty fast today. Here, this one. People think that this is a no solution, but it actually does have 2 solutions. So let me show you. I have 5 minus 2 times the absolute value of x plus 9 equals negative 5. So you get tempted to go, oh, it's equal to a negative. Nope, no answer. But you can't do that. You have to isolate the absolute value, then check it, okay? So we're going to get this absolute value, this absolute value of x plus 9 all by itself. So the first thing we're going to do is we're going to subtract this 5 over. Now, don't be tempted to do 5 minus 2 is 3. That's not true. This is 2 times this stuff. So we're going to subtract the 5 over to the other side. Yeah. So then we end up with negative 2 times the absolute value of x plus 9 equals negative 10. Okay? Still need to isolate that absolute value there, and I have a negative 2 times that. So how do I get rid of it? Divide. Yes. We're not going to add 2 over. That wouldn't make sense. It's being multiplied, so we need to divide it. And when you divide it, it reduces there. And you end up with an absolute value of x plus 9 equals 5. See that? Yeah. And so it's not saying an absolute value equals a negative number. It looked like it at first, but once you get all the stuff over, it fixed itself in a way. Okay, so now you get to set up your 2 equations. So you say stuff. It's a good mathematical term. That stuff equals 5, and stuff equals negative 5. I said and, but I should have said or, because you can't equal 5 and negative 5 at the same time. All right, so let's go ahead and solve these. X would equal negative 4, or x would equal negative 14. Pretty good? Yeah? Do you want to try one? Want to try one on your own? You think you got it? Have you been trying them? Yeah, with me? Okay. Then we'll move on to part B if you feel pretty comfortable, confident in your skills. By the way, this is one of those assignments that you need to show work on. Make sure you show work, okay? You've been doing that. You've been doing a really good job. All right, part B. Now, these ones are a little bit tougher, okay? These are the ones where you're going to have variables on both sides. Variables on both sides. So if you have something like this is just a quick little, it's not even an example. The absolute value of x equals x. What happens is you think there's going to be 2 answers, but a lot of times there's only one. So if I said, okay, let's try 2. 2 would be okay. If I got 2 as an answer, the absolute value of 2 is 2. But would negative 2 work? No. Okay? Because when you plug it into this side, you get the absolute value of negative 2 equals negative 2, and that one doesn't work. Okay? Yeah. So for these, when you have variables on both sides, you do have to check your answers. Because sometimes, and you didn't do anything wrong, you feel like you did, but once you get to the end, one of them doesn't work. Both of them might not work. You need to check your answers. And I even say that. On the quiz on Tuesday, I would say solve and check your answers for these. And then cross out one that doesn't work. So I'll show you what they look like. All right, number, what are we on, 6? 5. Number 5, a couple more. Suppose that you have the absolute value of 3x plus 2. And let's say that's equal to 4x plus 5. Okay? All right, so for these problems, we're going to solve the same way we did before. We're going to say this stuff is going to equal the stuff on the outside, and then the stuff's going to equal the opposite. So we're going to set that up. So write down 3x plus 2 will equal 4x plus 5. Okay? Or, you can split your page down the middle a little bit, or 3x plus 2 will be the opposite. And what's the opposite of 4x plus 5? Yes, you did it. You did both the negatives. Okay? So you got to do the opposite of both the 4x and the 5. All right, so now you're ready. You get to solve two equations. Yay. Don't you like these? No. All right, subtract the 3x to the other side. leaving you with 2 equals x plus 5. And then subtract 5 to the other side. So we get x equals -3. Okay, just hang on to that for a minute. Now go over to the other one. Let's add 4x to the other side. You okay with that? I like to keep my variables positive. And I get 7x plus 2 equals -5. And if you can do this in your head, the rest of it, that's great. I think that's really good. If you need to write down your work and subtract 2 over and then divide by 7, you get x equals -1. And you think, great, I did it right. But something happens. Let's try them and see if they work. So if I plug in -3, and I do the absolute value of 3 times -3 plus 2, I get -9 plus 2 is -7, and the absolute value is 7. Okay, but let's look what happens when I plug it into this side. Plug in -3, I get 4 times -3 plus 5, which is -7. Does 7 equal -7? No, it doesn't. So what I want you to do, I want to see that you got that answer, and then I want to see you do that to it. Just cross it out. Yeah. So we're trying to get these equal to each other, these sides. And when I plug in -3, it doesn't work. Now, please don't think you did anything wrong. Like, oh man, I messed up this problem. Nope. They actually have a name to these types of problems. What happened? Did I do it wrong?
Trick question. I have a question. Why did you use -1 instead of -3? Does it matter which one?
You need to check them both. I'm going to check. Yeah, I'll check that one in just a minute. Yeah.
I'm sorry, where did the -3
I solved and got it right here. So I subtracted 3x. I subtracted 5. 2 minus 5 is -3. I checked it. It didn't work. And they have a special name for these problems. They are called, maybe this will be the fanciest word you learned today, extraneous. It even sounds bad, huh?
Yes.
I know. Sounds like we strained to get it, and it was extra. And they're extra answers that don't work. It happens. It's going to happen now. It's probably never happened in your whole life in your math career, but they do. They occur. Okay, then we go over here to x is -1, and we check it. So let's check -1. So 3 times -1 plus 2, that gives me -3 plus 2 is -1. The absolute value is +1. If you can do that in your head, that's great. You know your calculator also has an absolute value button. Did you want to know where that's at? Okay, I'll show you in just a minute. And then on the other side, we do 4 times -1 plus 5, and we get 1 also. So yay, it checked.
Wait a minute.
You plug 1 in for both sides, and it works. Yeah?
You did 4 times -1 plus 5, isn't it -5?
No, it's plus 5. You have to plug it in. That's a really good question. You have to plug it into the original problem, the very original, not the one that you solved, but the problem that the book gives you or that I give you on the test. I should have mentioned that. Thank you. I'm really glad you said that. Because if you plug it into the one that you solved, it's going to work because you solved it, right? Even -3 would work. But you got to go back to the tip-top original problem that you started with. All right, those are tricky, huh? You didn't like that one. We're going to do another one just so you can see. Last one. Oh, I was going to show you where the absolute value is on your calculator. Have you gotten this calculator yet?
No.
You need to.
My parents said it's either this or a card, so.
Well, you need it by the next chapter for sure. And there's actually a day when you have to bring it to class, or I send you to go find one somewhere. Yeah, but you need to buy one. Graphing calculator, TI-84. All right, so here we go. The absolute value symbol it's kind of tricky to get there. You go to math, which is this button right here that says math. And then there's a whole bunch of stuff, but you want to go and scroll to the right to num, and there it is, ABS, absolute value. It's kind of a tricky place. So and then it even gives you absolute value symbols. So you can go 3 times -3 plus 5. That equals 4.
How do you get out of it though?
Ooh, good question. So if I go math num absolute value and I want to get out of it, I would go 3 times 6, you arrow to the right out of it, plus 6, something like that. Okay? You're going to get used to this. That's why I really want you to get this calculator as soon as possible so you start getting used to the buttons. All right, last one. Do we have time? Ooh. Shoot. All right, absolute value of 5x minus 2 equals 7x minus 14. Okay. Our absolute value is isolated on the left-hand side. It's completely isolated. And we're going to set up two equations. We're going to set up 5x minus 2 is equal to the outside, or split it down the middle. 5x minus 2 is equal to the opposite. What's the opposite of 7x minus 14? Good, you did it. Negative 7x plus 14. You got to change them both. Change both signs. Okay, then you have two equations to solve. You're welcome. Subtract the 5x. Negative 2 equals 2x minus 14. We're going to add the 14. So x equals 6. I'm going to show you a shortcut. You want to see a shortcut? You do. I'm going to show it to you. Just hold up. All right, over here, let's add the 7x to get 12x. And then let's add the 2 to get 16. So x will equal, you guys like decimals better, don't you?
No.
Oh, you don't? Oh, I thought you did. Oh, yeah? This one's 4/3. Okay, here's the shortcut to checking. You really only need to check one side. Okay? If you check this side and you get a positive number, then you're good. It's kind of a little shortcut. So if I plug in 6, I'm going to get a positive number there. If I plug in 4/3, 7 times 4/3 minus 14, that's a negative number. That can't be, right? I can't have an absolute value equal a negative number, so I can cross that out. Okay? So it's just a little bit of a shortcut. You still have to check, but if I plug that in, plug that into there, this ends up being positive, this makes it negative, I need the positive one.